Hello everyone, my name is Abhishek and welcome back to my channel. And also welcome to one more episode of AWS Zero to Hero series. In this video, I'll deep dive through one of the most complicated topics of AWS, that is Virtual Private Cloud, also known as VPC. So today's class, let's learn what is Virtual Private Cloud. Let's understand why you need Virtual Private Cloud, what are the different components of Virtual Private Cloud, and also how do they interact with each other. And finally, there is a fear amongst a lot of people that virtual private cloud is a difficult topic. You might say that, yes, Abhishek, we have that concern because VPC involves a lot of networking. There are multiple components, and it's difficult to understand why and how each of these component is interacting, what purpose all this solving. So don't worry if you have any such fear, or even if you are completely new to networking and VPC. After today's video, you along with me will say that virtual private cloud is an easy concept, and I understand this concept end to end. So we will do practicals as well, but practical will not be part of today's video because it is very important to have strong foundational knowledge on VPC. So today's video, I will try to add that foundational knowledge on VPC for you. And in tomorrow's video, we will deep dive into slightly more complicated topic of VPC that is related to security. And in day after video, we will try to do a practical video, deploy application inside VPC and explore the complete flow of VPC. So that will be the entire thing. But how will I make this concept easy for you? You might ask me. What I'll do is I will take a real life scenario. Okay, so we will take a very much real life scenario that all of us understand, and we will use the same real life scenario to understand the concept of VPC. So this real life scenario has nothing to do with AWS, but still I will correlate and make this concept very easy for you in the lines of AWS. So let's quickly start the video and understand virtual private cloud. So to start with the example, the scenario that I was talking about, let's say that there is a huge land. Okay, so let's call this as a village. Okay, so we have a village and there are a lot of people in this village, but there are specific set of lazy people in this village. Okay, so these lazy people are lazy enough that they can't construct their own houses. Why they can't construct their own houses? Because they don't want to maintain their houses, they don't want to manage their houses, and also they don't want to go through all the construction process and everything related to their houses. So these people, they are actually looking for some people, and at the same time there is one wise person in this village. Okay, let's say that this wise person is called ABC. So there is a wise person called ABC in the village. What he has done is he saw this opportunity of lazy people and he said that, okay, let me grab this opportunity and make money out of it. So this wise person ABC, what he has done is he went to this village and he acquired a huge land in this village. Okay, so he acquired this entire land in this village and he said that, okay, hey lazy people, what I'm going to do is I'm going to construct the houses for you, but for that you have to send me a request with your entire requirements, like what are the resources that you require in this house, what is the capacity that you require in this house, and fill me all the details and give it to me, and in return I'll give you house and I'll take money from you, right? So this person has started the process, and what this ABC or the vice person has done is he has constructed this house in the land that he has acquired. So he purchased this entire land and he constructed a house and he said that I'll maintain this house for you. So this person felt happy for it, and then seeing this other person also approached and he has constructed house for the other person as well. So in future there is one more person and he has constructed house for that one more person. So it is going well, and all of these people, their problem is solved, that they don't want to maintain the entire construction and maintenance. This person, the vice person ABC, is taking care of it and they are all happy. But there are other bunch of people. What they have done is they saw this, they were happy about it, but they realized that these bunch of people, they have realized that there is some kind of security issue here, there is some kind of privacy breach. That means for the purpose of saving a lot of money, what this person has done is he has constructed the houses, but they are very nearby and there is some kind of security breach that anyone who access this house can hack hack or access the other house and can also access the other house. So that way there is some kind of security breach that is happening here. So these people said that, okay, we are also looking for houses from you, but we want it in a much better way, not in this way where if one of these houses is compromised, that the other houses are also compromised. So this person, to not to lose the business and because he want to construct more and more these things, what he said is, okay, give me some time, and he came back with a new concept called secure land. Okay, so what he said is, okay, I have this entire property, but if you come as a group, where if you want a group housing or something, what I can do is I can build a secure property for you people. So inside this entire land, what this person ABC has done is he has built a secure property for these people. And this secure property, what he said is only people who have access to this secure property. Like he said that I'll construct a gate here, which will act as a gateway, right? So this gate will act as a gateway, and only these people or the people's relatives or people who know these people only can enter this secure property, right? So what happens is, let's say someone wants to meet this person, okay, and this person has one property here, the other person, this person has one property here, and this person has a property here, right? So now there is one of the relatives of this person, right? Let's call this person as A. Now the relative of A wants to meet this person. So what the secure property does is, this person can definitely meet him, but he first has to pass through this gate. So there can be a security guard or someone who will guard this property. And once he enters this, so this is a property that all of these people own, right? So this secure property, this is all the public thing where everybody owns this. But if this person, this XYZ person, let's say he wants to go and meet this person called A, now he need to understand how to go to this property, right? Now, because I'm drawing this picture, you know how to go from here to here. But eventually, to go from here to here, there has to be another guide here. So this guide basically explains, okay, move from here to here, and finally you'll reach the person A. Again, once you reach this person A, there will be another security guard, or there will be some kind of person here who will validate, okay, is this the right person? You entered the gateway, you moved into the secure property, but again, do you want to meet A? Do you want to meet B? Do you want to meet C? So if you are a valid person who wants to meet A, then only I will accept your request to meet the person A. So this way, what this ABC, the vice person, has done is he has solved the problem of security breach and solved the problem of security. And now everybody is enjoying the secure property. Looking at these people, there are another bunch of people who came to him and he has built another secure property, another secure property, another secure property. This way he started making his business. Now, why did I explain this story to you people? You might be thinking, has Abhishek gone mad? Why is he saying all of these things? And how is it going to be related to AWS? Okay, now let's try to relate the same thing to AWS. In the last class, I showed you how to create an EC2 instance, how to deploy an application, and how to access that application, right? So now let's go to the same scenario where there is this big region. Okay, so let's call this region as Mumbai or Ohio or whatever you would like to. What happened was, there are people. Okay, so there are companies, let's say this company as example.com, this company as example1.com, then there is another company called example2.com. So these people, initially they were maintaining their own data centers, but it was becoming too hectic for them. So they said that, okay, if there is someone who is going to help us with this data center, we will offboard that to them. Or there is a new startup. Now they said that, okay, we can't afford to build a new data center, we can't afford to maintain it. Now we are also looking for someone. So AWS saw this opportunity, right? So in this case, who is the vice person? AWS is the vice person. What AWS said is, hey, okay, what I can do is, inside this region, let's say there is a region called Mumbai or Ohio or throughout the world, what AWS did is AWS started building their own data centers. In the previous example, that person has acquired a lot of land, right? The vice person. Here, what AWS did is AWS started purchasing or building their own data center. So AWS built this entire data center in Mumbai region, for example, or Ohio region, or Frankfurt. Anywhere, AWS started building their own data centers. Now what AWS said is, hey lazy companies, or hey startup, hey example 1, example 2, example 3. So we can host your applications inside our data centers, or you can request us saying that, hey, I want one virtual machine, I want 10 virtual machines, I want 20 virtual machines, and we will take your request. You give me money and I will create the instances for you. So this was going I mean, this exact same thing what we did previously, and this was going very fine, where example.com one, they requested, and what AWS did. So this is the story of 2013 2014. Okay, so during this time, what AWS did is, if example.com is requesting it 10 EC2 instances, so it went to the data center in region Mumbai or whichever region it requested, and it created 10 EC2 instances. Okay, so again, inside the data centers, there will be multiple physical servers. Let's say this is a physical server, and example.com requested 2 EC2 instances, so it gave 2 EC2 instances inside this server. Let's call it server 1. So then there is example 2, and what AWS did is it created again request of example 2 in the server 1 only. Then there is example 3, and what AWS did is again it went to here and it created server. Let's say it requested for one server, it created in server 1 only. Here what I'm talking about, virtual machine 1, two virtual machines, and 2 virtual machines. So this is fine. All of this problem is solved, and AWS is also giving them virtual machines inside the data center. Inside data center, like I told you, there can be multiple servers. For one server, AWS choose one server and solved all of their problem. But what happened is, let's say, so this is a theory. What can happen is that in this case, so if there is a hacker, and let's say this is startup, okay, let's say this is startup. If there is a hacker here, because they were not maintaining proper security, he entered into this server. He tried to make some false request to this application inside the virtual machine, and he was able to hack this particular server. Now, because all of them are in the same physical server inside the AWS data center, hacker can easily come here. Hacker can easily come here. Hacker can easily come here, and he can hack the entire thing, right? So just because of example 3, or just because of startup, what happened is all of the servers are hacked, because AWS was creating entire instances, or AWS was creating all the things in same things, or it can also create in different things. But what happens if it creates in the same server, right? So till 2013 2014, this was happening. So to solve this problem, like I told you, even in the previous example, to solve the security breach, what AWS said is, okay, we will come up with a new concept. In that case, it was secure community. In AWS terms, it is called as VPC, right? So what AWS said is, we will build a VPC for you. Or in the other way around, like in the previous case, the builder will build the entire secure community and give it to you. But in the AWS terms, AWS will give you documentation. AWS will give you examples. Who is the one who builds this entire VPC and maintains the VPC? It is DevOps or AWS DevOps engineers. Okay, so AWS DevOps engineer, looking at the documentation of AWS, they will go to the AWS portal and they will request for the VPC, and they will configure everything inside the VPC. Now let's see what is inside the VPC using the same example itself. In the same example, what I told you, I'll try to convert that into AWS example, right? So this is AWS data center again. So there is, let's take example of one company here. So let's say there is TCS, and inside TCS, there is one project, and this project is owned by a DevOps engineer. So what this DevOps engineer does is, he will go to AWS, and let's say there is a region called Mumbai. He'll go to AWS and say, hey AWS, give me a VPC. Now, how do you define the size of a VPC? In the previous case, because it was a land, you can define the size of land in some acres or in some hectares or something. But how do you define the size of a VPC? So for defining the size of VPC, there is something called as IP address range. Okay, so what is this IP address range? So IP address range, whenever a DevOps engineer creates a VPC, what AWS asks is, what is the IP address range? So if you say, for example, the IP address range is 172.16.0.0/16, that means AWS will allocate 255 into 255. Now don't worry about this calculation, what is Abhishek calculating and what is happening here. You will understand this in future. For now, understand that AWS will give you 65536 IP addresses. Okay, so how do you define the size of a VPC? You can define the size of VPC using the IP address ranges. So DevOps engineer will say, hey, for our project in TCS, I need this particular IP address range for the VPC, which means I need 65536 IP addresses. So technically you can assign this IP addresses to 65536 applications, instances, whatever you would like to call to, right? So this much IP addresses can be allocated using the VPC. But what DevOps engineer will do is TCS can be one project, but inside the project, there will be multiple sub projects, right? So there can be one project related to payments, one project related to transactions, one project related to XYZ. So what this DevOps engineer will do is for one internal project. Let's say there is one internal project here. There is one internal project here, one internal project here. So this DevOps engineer will split the IP address ranges, right? So what he will say is, okay, for this particular sub project, this particular sub project and this particular sub projects, divide the IP addresses. So here he will say 172.16.1.0/24. 2.0/24, 3.0/24. So this particular thing will get some 255 IP addresses, this particular thing will get some 255, and this particular will get some 255. Okay, now again, don't worry about the calculation, how Abhishek is calculating and all. That is irrelevant to this discussion. For now, just understand that for TCS, there will be internal projects, and depending upon the internal projects, this DevOps engineer will split, saying that, okay, even the VPC might have one IP address range, but I will split them to three different IP address ranges for three projects. And this particular concept is called subnet. Okay, the name itself says that it is subnetwork, right? So it is subnet. What you are doing here, the VPC is created with a particular IP address range. You are splitting the IP address for your sub projects. DevOps engineer is splitting this for the sub projects, calling it subnet. And inside this sub project, let's say this sub project has only one application. So you deploy an EC2 instance and you deploy that application. Here there can be two instances. Here can be three instances. Depending upon the sub project, it is up to the sub project development leads how many applications do they want to deploy inside a subnet. They will contact a DevOps engineer as well. But for now, let's say this is the configuration. So there is sub project, sub project, sub project, one application, two applications, three applications. So now what DevOps engineer will do after this, once he creates the subnet and all, now DevOps engineer, like we discussed in the previous example, he will create a gateway, right? Why is this gateway required? If there is no gateway, nobody can access this particular VPC, right? So without a gate, nobody can enter the gated community or the secure community. Similarly, without this gate, nobody can access or enter to this entire property itself. Let's say there is a relative in previous case here. Let's say there is a customer who wants to access application in this EC2 instance. There is customer who wants to access application in this EC2 instance. So he has to definitely come through this gateway itself to the VPC. So firstly, there will be a gateway, and what this gateway will do is, gateway is just like a pass for someone to enter to this VPC. Now, once they enter, what will happen? Like I told you, this is one subnet, this is one subnet, and this is one subnet. But this is all a free space, right? Inside the VPC, these are the subnets which we call as private subnets because they don't have access to internet. But then there is something called as public subnet, right? So what is public subnet? Public subnet is the one that a user first access inside the VPC. So how does public subnet connect to the user, or how does public subnet connect to the internet? Basically is using the internet gateway. So this particular thing, this particular gateway here, we call it as internal gateway. Sorry, internet gateway. Through the internet gateway, there is a public subnet from which the user enters to this. Okay. Once the user enters, basically there, let's say there is a load balancer here. Okay, what is load balancer? Load balancer is the one that forwards the request depending upon the load. For example, there is this application and the user from the internet want to access this application. Now, how will the request from this public subnet from the load balancer goes to this application, right? So there has to be a particular path. So for this public subnet, what you will do is you will create something called as a router. In AWS terminology, you will call it as a route table. So you will create a route table. This route table defines how should application or how should the request go to the application, right? So you have a load balancer. Load balancer can send the request depending upon the target group. We will discuss about load balancer in detail later, but for now just understand that there is an internet gateway. Once from the internet gateway, there is a public subnet. From the public subnet, request goes to the load balancer. Load balancer is assigned with the public subnet, and for the load balancer, what you will do is you will create a target group of this application. Okay, so now what happens is if the request from the load balancer has to go to the subnet, load balancer does not know how to go to this particular thing. So what you will do is for this subnet, you will create something called as a route table. Okay, so this route table defines and tells the load balancer, okay, go through this particular path so that you will reach me. And once the request from internet now reached here, but still at the EC2 instance, like I told you in the previous example, there can be a security guard here who can block your request. Similarly, for the EC2 instance, there can be something called as security group. Okay, so there will be something called as security group, where this security group can say, okay, so on which port do you want to access me, or from which IP address are you coming from? What is your IP address? Then the security group can say, okay, only if it is coming from this particular IP address in the internet, only if you are trying to access me on a particular IP address, then I will allow the access, and that way you will finally reach your application. Okay, so what is happening on the whole? If someone from the internet is trying to access an application in the private subnet here, first of all, the request has to go through the internet gateway. Once it reaches the internet gateway, it will go to the public subnet in the VPC. Right? What is public subnet? It's a common subnet across the VPC. Once it goes to the public subnet, there is a load balancer here, right? What is load balancer doing? Load balancer is attached with the public subnet, and load balancer has a target group. So when request goes to the load balancer is the one that takes the request to the private subnet and to the application, right? So to reach, I mean, for the load balancer to understand how to go to this application, the subnet is here, but what is the route path for the subnet? So there is something called as route table, right? So route table is the one which defines the path. Once the path is defined, it can go here, but still there is something that can block, that is called as a security group. Once the security group also allows you, your request is finally reached. Now let's try to write these things, okay? So that you understand what exactly has happened. First of all, from the internet, right? So let's say this is internet. There is person in the internet here. He is using a laptop, and what he is trying to do is he is trying to, let's say, access an application which is called, for example, example.com, or okay, let's leave the a domain, and let's call he is trying to reach something called 172.16.3.1 slash something. Okay, in general, he'll not use the private IP address. He will use the load balancer IP address to reach there. But for your understanding, let's say he's trying to reach one application in the private subnet. Okay, so to reach, what I have told you first is there is a DevOps engineer who has created a VPC, right? Inside the VPC, what is there here? There is basically an internet gateway. Okay, so let's say this is the internet gateway. And then inside this VPC, right, if you call this entire thing as VPC, which has a basic IP address block or the IP address range, this entire thing has a IP address range. Inside this, what he has done is for project A, he has created a subnet. Project B, he has created a subnet, and project C, he has created a subnet. Again, what is a subnet? This is the entire IP address range. So for each project, you can divide the IP address range. If this IP address range is 172.16.0.0/16, this can be 172.16.1.0/24, 2.0/24, 3.0/24. That way you can split. Now let's say there is one application inside this subnet, one EC2 instance, and end goal is to reach from here, from the internet, which is completely outside of VPC. You want to reach from here to here. Okay, so what is the process? Firstly, it will come here. It will see that there is an internet gateway here. It will pass through the internet gateway. And once you pass through the internet gateway, like I told you, there is a public subnet here. Okay, what is public subnet? Public subnet is the one that can be accessed to the public outside the VPC. But they have to pass through the internet gateway. Once they pass through the internet gateway, in the public subnet, there is something called as load balancer. In AWS world, you will call it as elastic load balancer. Okay, so you have elastic load balancer. It can be application load balancer, network load balancer. We'll talk about that later. Now you have an elastic load balancer here. So what this elastic load balancer does is your request from the external world has reached the elastic load balancer. From the elastic load balancer, now it has to go here. But how will the load balancer understand that it has to go here? This is a private subnet, right? But for elastic load balancer or for the load balancer to send your request to the private subnet, there has to be a proper route. Okay, so who will define this route? There is, like I told you, something called as a route table. Okay, now you need to have a route table, and using this particular path, your request has to flow, right? So what you will do is for elastic load balancer, one thing, you will attach the private subnet and you will attach the target group. Okay, so what is target group? You will understand when you learn more about the elastic load balancer. But for the load balancer to understand request has to go here, firstly, you need to create something called as target group, and you have to assign this instance to the target group. And at the same time, the subnet should have the route table so that the traffic is flowing here. Okay, so and here, like I told you, there is a security group which can block the request or accept the request. So these are the entire flow. What are the components that we talked till now? One is internet gateway. Then we talked about public subnet. Then we talked about load balancer. Then we talked about route tables, which are basically routers in other terminology. So routers are the one which forwards a request. Even from your home laptop, if you're trying to access a particular website, there are routers and there are multiple hops. Using multiple hops, different routers connect to each other and forward your request, and finally your request goes to a particular server. Even in AWS, that's the same, but you call it as route table here. So you have route table that you understood. Then you understood about security groups, right? So these are the critical components of VPC. Additionally, there are few things which I'll cover very quickly, but in future class, that is in tomorrow's class, we will talk about them in detail. One is like, let's say you have one security group here, you have another security group here, you have another security group here. Okay, but within a subnet, okay, if you want to define the same security group to multiple applications, multiple EC2 instances, or you want to repeat the security group configuration, there is something called as NACLs. Okay, NACLs are basically automation for your security groups, where instead of defining the same thing again and again, you can define that as part of NACLs. Okay, and finally, there is one more concept that I will explain and I'll conclude today's class. That is the concept of NAT gateways. Now, what is NAT gateway? I'll try to explain in this scenario itself instead of directly explaining you the example and say the concept of NAT gateway. Now the request from here has reached this application, which is well and good. But now what if the request, now what if this particular application here tries to access something from the internet? Okay, now till now we talked about this workflow, right? Workflow flowing from here to here. But what if the application tries to access something from the internet from google.com? Let's say this application wants to download a package, which is quite common, right? You might want to download something to your server. So there is a server here and you want to download something from internet. So what is the problem here? You might say that, okay, again, it can use the public subnet and it can flow and it can access it. The only problem is that, okay, the request can flow. How the request will flow is a different challenge. We will discuss that. But the only thing is, when someone tries to access some resource from the internet, one of the critical things that you have to remember is if this is in the private subnet, that means that there is some sort of security here. So it is a bad practice to expose your applications or to expose your server's IP address to the internet. Okay, so whoever is receiving this in the internet, so let's say you are trying to download something from xyz.com. Okay, so xyz.com should not know the IP address of your server, or it should not know the IP address of your application, anything. It should not know it should not know the IP address of your private subnets, applications, or the servers, EC2 instances. Okay, so how do you avoid that? You need to do a masking of IP address. Okay, so this masking of IP address is called as NAT gateways. So what does NAT gateways do is they will send you the request. They will help you to download some resources from the internet. But when you do that, it will try to mask the IP address and it will change the IP address with the public IP address, either of the load balancer or either of the router. So if it is doing using the load balancer, we call it SNAT. If it is doing through the router, we call it as NAT gateway. Okay, so what is NAT gateway basically doing? It is helping you to download the resource from the internet, and at the same time, it is helping you to mask the IP address. So without masking, what will happen is, again, there can be a hacker who will know your IP address and he will try to do something with your network. So to avoid that, this NAT gateway, which is a concept which is available along with the ALB. Like if there is ELB in the public subnet, you will create NAT gateway also in the public subnet only. Okay, so NAT gateway is created in the public subnet, and what NAT gateway will do is, like, there can be NAT gateway here, NAT gateway here, anywhere. And what this NAT gateway will do is it will help to download the package from internet, and at the same time it will mask the IP address so that this person will not know the actual IP address of the server or the actual address of the application. That way your entire thing is secure. Okay, so these are the different components of VPC. We have learned a lot of concept today. Now your assignment would be to write down all of these components and go through the AWS documentation and see whatever I have told you, are you understanding it or not? Also, most of you people know that there is a GitHub repository for AWS entire thing that we are learning. Even in that, I have created a few notes, so you can go through those notes and you can validate your understanding. Did I understand it correctly? I have put some reference links. I have put some diagrams. You can go through those diagrams and evaluate if your understanding is correct or not. End of the day, what I would expect from today's class, if someone is watching today's class, they should understand what is VPC. They should understand why a VPC is required. Why did I explain this example and how this example is correlating with the example of AWS VPC? I hope you understood it. I hope I explained it pretty much in a layman terminology, what is the entire flow and all. When we do the practicals, you will definitely understand this in an even better way. Right now, these are the entire things. These are the different components that are involved in a VPC. I've covered most of the components, if not everything. There is one more thing, sorry. There is one last thing. If you want to debug this entire thing and if you want to understand this entire flow of how the traffic is flowing and what is happening, how many requests have come to the VPC and all, there is one final concept that is called as VPC flow logs. Okay, so VPC flow logs also does the same thing where it records every action. Whatever I explained, like here I will explain that traffic is going from here to here, what is happening, which server is getting the request. So there is one particular thing called as VPC flow logs, which is chargeable. So inside the VPC, there are few things that are chargeable. There are few things that are not chargeable. When we do the practicals, I'll also explain that. So finally, if you found today's video informative, definitely share the feedback with me. Put it in the comment section. Abhishek, I have understood this, I have not understood this. I'll really appreciate your feedback. And if you know someone who wants to understand VPC and this entire concept, please share the video with those people. Thank you so much for watching the video. If you haven't subscribed to the channel, please subscribe. Take care, everyone. See you all in the next video. Bye.